Hi, this is the first video for hypothesis testing for year 1. So, hypothesis testing is a complicated concept. In general, a hypothesis test is a method for testing a claim or a hypothesis about a parameter in a population using data measured in a sample. So you could do hypothesis testing using lots of different statistical calculations, and in fact, you'll over the course of the 2 years, you'll do it with 3 different types of calculations. So what it means by a parameter, well, that's the thing that you're calculating. So, for example, you could, let's say, collect some data of 20 people and measure their height and weight. And it may be that you are looking to see if there is correlation between height and weight. So you collect your sample, you draw your scatter graph, and you conclude that there is strong positive correlation between height and weight. Now, what that is that is a measure of the correlation for your sample. And what hypothesis testing is a way of deciding whether, based on your sample, you have got enough evidence to say that there is strong positive correlation between height and weight in general for the whole population. So you're using what you've got for your sample and you are testing whether that is enough evidence to suggest that what you found out is true for the whole population. You could do it for different things. You might, for example, let's say take the heights of 200 boys from college, for example, and calculate probabilities based on that of a person being over a certain height. So you could compare those probabilities and test to see if there is enough evidence to suggest that the whole population's height follows that same probability pattern based on your sample. So there's different uses and different things that we can compare, but it's basically you are using information that you calculate based on a sample and testing to see if you can say if the same results would be true for a population or not. Now, you are going to be using it next year for something called a correlation coefficient, so something similar to what I've just been talking about, and something called a normal distribution. This year, you need to use it in conjunction with the binomial distribution. So remember, that calculates probabilities for a certain type of probability distribution and looking to see if those probabilities infer something about the population. It's quite a difficult concept, so hopefully you'll have more of an understanding about what's going on later. There's lots of terminology to do with hypothesis testing, and there are lots of symbols that we need to use. So just to try and explain what that is, I've come up with a bit of an analogy. So if we consider what happens in a court of law. So if someone is accused of a crime, then there are 2 important principles that operate under the system of law. The first principle is that the defendant is innocent until proven guilty. So basically, we are making an assumption that the defendant is innocent. So that's our default assumption. And we then have to use information to either disprove that and therefore assume that the defendant is guilty, or we will not get enough evidence and therefore the defendant will be concluded to be innocent. To disprove that the defendant is innocent, so in other words, to prove that he's guilty, where the jury and the judge have to answer the following question: is if the defendant is innocent, then what is the probability of obtaining the evidence presented? So if the defendant is innocent, then you would expect that there will be zero chance of finding any evidence, or a very small chance of finding any evidence. But if that probability is small and yet evidence has been found, because the probability is small and but the evidence is there, then the defendant must be guilty. But what we need to consider is how small is small. So the chances of it finding evidence has got to be small. But what is small? Well, in hypothesis testing, we use actual values, and you'll be given the actual value in the question. So, how does this link to hypothesis testing, and what is the terminology? So, a hypothesis is just another word for a claim or a premise or a statement, I suppose, that we believe to be true. And we start off with what we call the basic assumption, and we call that the null hypothesis. And we write that as an H with a little subscript 0. So that's the null hypothesis. And that is the thing that we believe to be true, the default statement. So in the case of the defendant, it's that he's innocent. Then we have the alternative hypothesis, which we call H with a little subscript 1, which would then be our counterclaim. So there's something that we're trying to prove or show. Once we've got our hypotheses, we will then, using information from a sample, do some calculations relating to a test statistic. You'll understand what that means shortly when I go through an example. And then this is compared to what we call a level of significance, or a significance level. So that is the chance of something happening being small. So this is how small is small. So usually it'll be 5% significance. So you want the probability of something happening to be less than 5%. Sometimes it's 10%, sometimes it's 1%, sometimes it's 0.5%, but you'll be told in the question. Okay, then using our calculation and working out the probability of it happening, if it's small enough, then we will reject the null hypothesis and say the other one must be true, or if it's not small enough, we will fail to reject the null hypothesis. So it's all about either rejecting the null hypothesis and therefore accepting the other one, or it's failing to reject the null hypothesis. In terms of this significance level, if a 5% significance level basically means that we're happy to be 95% confident that we are correctly rejecting the null hypothesis. I'm just going to talk you through one particular little mini scenario just to show you the beginnings of what is going to be happening with these questions. So this is hypothesis testing with the binomial distribution. So Here we have got an example. We've got the title one-tailed test, so there's one-tailed test and two-tailed tests. You'll understand what the difference is and how to do them when we get onto them properly in the next videos. A six-sided dice is thrown 30 times and X, the number of sixes, is recorded. Now, what sort of distribution is this? Well, this is a binomial distribution, so all the questions that you do will be of similar variety. It's a binomial distribution because the number of sixes recorded, that would be our probability of success, getting a 6, and then a failure would not be getting a 6. So we have two outcomes, success and failure. We have got a fixed number of trials, which is 30, and there is a fixed probability of success, which we know is a 6. So we could write that information as X is distributed binomially. Remember, we've got N, which is 30, so that's the number of trials, and then P would be the probability of success, the probability of getting a 6, which is a 6. So this is an example of something that is binomially distributed. Now then, if you threw the dice 30 times, and in order to win, let's say it's a game, and in order to win you needed to get a 6 or some 6s, what would be the expected number of wins? So if you won, if you got a 6, then in 30 throws you would expect to get 5 6s. So that is 30 times by 1/6. So this is N is 30, and then this is 6. This is called the expected outcome. So the expected outcome is the product of the number of trials and a 6. The probability of success, sorry. So in this case, the expected outcome would be 5. You'd expect to get 5 6s out of 30. Okay, so let's say this is a game and we throw the dice 30 times. Now, based on the fact that we are assuming that that dice is fair, then our null hypothesis is going to be that P is 1/6. So that is our null hypothesis. We are assuming that that dice is fair. But let's say someone plays the game and throws the dice 30 times and they don't get a 6. And they say, actually, I don't think the dice is fair. I think it's loaded. It's not giving me a 6. Then the alternative hypothesis would be that P is less than 1/6. Because what they're saying is, well, I don't think it's fair. I don't think it's a fair one. And because I didn't get any 6s, I think the probability of getting a 6 must be less than that. And that would be our alternative. So using the hypothesis test, we would then look to compare and see whether there is enough evidence based on the fact that they got no 6s to say if this is true or not. Okay, or it could be someone plays the game and they get 15 6s. So in that case, you might think, actually, it's not a fair dice either. We might think that there's a higher than a 6 chance of getting a 6, and we would look to see if we can prove this. So that's what it's about. It's using information for binomial distribution